Hello everyone. The title of this video is Rationalize a two-term denominator. All right. Now every exercise I do in this video, every example, is taken directly from this free online textbook at openstacks.org, and it's titled it's their Intermediate Algebra 2nd Edition textbook. And I'll be working on exercises under the heading Rationalize a two-term denominator. Now I'm only going to be working on the even numbered exercises, so starting with 272 and going up to 282. You'll notice that the odd numbered exercises have links that you can click on and see the solutions in the book. Alright, so I'm going to be working on the problems that don't have solutions in the book. I will also be putting timestamps for each exercise in the description of the video below. I'm going to call exercise 272 example 1, 274 will be example 2, example 3 will be 276, and so on. All right. So hopefully, if you want to see any particular problem, you can just jump to it by clicking on the timestamp. And one other thing I request of you is that when I bring up a new problem, pause the video and try to work on that problem yourself first, and then see how I did it and compare. Because if you're just watching me do these things without practicing yourself, chances are you're not going to learn all that much. Alright, so the first question will be exercise 272. I've got them written down. Here we go. And we're asked to rationalize the denominator and simplify. Now hopefully you recall, you've been watching my other videos maybe. And I did a video on rationalizing a one-term denominator. Rationalize just means write an equivalent expression that has no radical in the denominator. Alright, so we want pardon me, we want no radical symbol in a denominator. So no radical in a denominator. Okay. So for this number 1 here, which is exercise 272 in the text, we have a numerator of 7 and a denominator with two terms, positive 2 and negative square root of 6, right? 2 minus the square root of 6. But there is a radical, right? A root, square root of 6 in the denominator here. Now, some of you who remember how to you might think, oh, can't I just rationalize this the same way I rationalized with one term? So let's try this off to the side. So I'll write that 7 divided by 2 minus the square root of 6. Pardon me. And you might think, oh, I'll just rationalize this denominator the same way I did with one term. I see the square root of 6 down here. Again, it's got multiple terms, so I'll put it in parentheses. I see the square root of 6 in the denominator. So I'm just going to simply multiply the numerator and denominator by the square root of 6. Now this is where you got to be aware that this is not going to rationalize the denominator, because the denominator has multiple terms. This square root of 6 needs to be distributed to both those terms. So I would end up with 7 times the square root of 6 in the numerator, and then in the denominator I'd have 2 times the square root of 6 minus the square root of 36, or just minus 6. But do you see how, there's still a radical in the denominator? Right, the denominator still has a radical. Alright, so what do I do? With these expressions that have a denominator with two terms and a square root, and I'll tell you right now, all these examples we're going to see in this video have just square roots in the denominator with these two terms, because this method I'm going to describe will only work in rationalizing when you have two terms with a square root. So if you have two terms with a cube root or a fourth root, you're going to have to do something else. So what do we do? All right, well, remember this. Remember what happens when you multiply by a conjugate? So say I take a plus b and multiply by its conjugate, a minus b. Do you recall that when you multiply two conjugates like this, you end up with a difference of squares? You end up with a squared minus b squared. So this is the key to rationalizing these denominators with two terms and some square roots. So I'm going to take this original expression, 7 divided by 2 minus the square root of 6. Again, it's got multiple terms, so I'll put it in parentheses. I'm going to multiply the numerator and denominator by the conjugate of the denominator, which would be 2 plus the square root of 6. Alright. And do the same, to the numerator, 2 plus the square root of 6. But we're multiplying, so that the product in the denominator is a product of conjugates. Alright, conjugates. Alright, now the numerator, just multiply out and simplify, right? You're going to distribute the 7. So in the numerator I have 7 times 2 is 14. 7 times positive square root of 6 is just positive 7 times the square root of 6, right? Those don't get multiplied together because one is a radical and one is not. Alright, so there's the numerator. The denominator, a minus b times a plus b, would be a squared minus b squared. 2 squared minus the square root of 6 squared. Well, that's just 4 minus 6. So we have 14 plus 7 square roots of 6 divided by, 4 minus 6 is negative 2. And do you see now that the denominator is rationalized, right? There is no more radical. Now, I personally do not like having a negative coefficient in the denominator, so I'll just move that out in front of the fraction here. So this is negative, and then 14 plus 7 times the square root of 6 divided by 2. Right. Or you could put the negative in the numerator and make it negative 14 minus 7 root 6 all over 2, but either way is fine. Either way is fine. And there you go. And the numerator and denominator do not have a common factor. If you factor out 7 again, 7 and 2 don't have a common factor. So that's it. That's as simple as that gets. And it's got a rationalized denominator. Alright. Now what I'm going to do, just for this first page, is I'm going to use a calculator to check my work. And I would suggest that you do that as well for other problems. So I'm going to pull up a calculator. I have a TI-84 Plus simulator. I'll enter the number we were first given. Right, that was 7 divided by, and then in parentheses, because there were multiple terms in the denominator, 2 minus the square root of 6. And then close those parentheses. Alright, and that gives me negative 15.57321141, and so on. Alright, so that was the original expression. Now I'm going to enter what I got in the end with the rationalized denominator. So that's negative, and then the numerator has multiple terms, so I put parentheses. 14 plus 7 times the square root of 6, and then all that divided by 2. And this is what I got here. And let's see. Indeed, it is the same value. So that means, I did a good job. Alright. So same value, but a rationalized denominator. So that's going to be key, right? Remembering that multiplying two conjugates gives you a difference of squares. Alright, so same thing for number 2. Number 2 is number 274 in the text. Got 5 divided by 4 minus the square root of 11. I'm going to multiply the numerator and denominator by 4 plus the square root of 11, right? It's the conjugate of the denominator. At this time, instead of multiplying the numerator, because I want to simplify the fraction at the end anyway, I'll keep the numerator factored for now and see if we have any common factors at the end. So we have 5 times the quantity, 4 plus the square root of 11 in the numerator, and then these conjugates down here, we'd end up with 4 squared minus the square root of 11 squared, which is 16 minus 11. So that's 5. So we have 5 times the quantity 4 plus the square root of 11 in the numerator divided by 16 minus 11 is 5 in the denominator, and there is definitely a common factor in the numerator and denominator. You see a factor of 5, those become 1. And then all I'd be left with is 4 plus the square root of 11. And there you go. Definitely a rationalized denominator, right? The denominator here is 1. No more radicals. And then once again, I'll test it out. Use a calculator to check my work. So the original expression was 5 divided by the quantity, right? It's got multiple terms in the denominator, so I use parentheses. 4 minus the square root of 11. Alright, so that's 7.3166247.9. Okay. And then my final result after rationalizing, right, the denominator was 4 plus the square root of 11. See if that gives me the same result. 4 plus the square root of 11. And yes, it is. Yes, it is the same value. Fantastic. Alright, so like I said, I'm only going to do that calculator checking for this first page. I will leave the rest to you. Now the rest of them will have variables in it, but you can just plug in values for the variables and use your calculator to check and see if the expression in the beginning has the same value as the expression at the end. Alright, and same stuff here. Question 3, example 3, number 276 in the text. The numerator is the square root of 5, and the denominator is again 2 terms with some square roots showing up. The square root of n minus the square root of 7. So if that's the case, right, in order to rationalize the denominator, you need to multiply by the conjugate of the denominator, which would be the square root of n plus the square root of 7. Now you know what, before I continue with this, I'll finish this writing here. So I'm multiplying the numerator and denominator by the square root of n plus the square root of 7. Before I finish, I should have pointed out that there's a variable here, And remember, usually when there's expressions with variables, we like to, well, I like to, point out the domain of that expression first. What's allowed to be plugged in. Here, n has to be greater than or equal to 0. Right? It has to be positive, because if we take the square root of a negative number, that's not real. Right? We're dealing with real numbers here. N can be 0, right? Because if that was 0, you'd have 0. The denominator would be minus the square root of 7. The only value n can't be is 7. Right, so off to the side, I just put some restrictions on the variable. It can be any non-negative number I want except 7, right? Because if I plug in 7 for n, you'd have the square root of 7 minus the square root of 7. You'd have 0 in the denominator, and that's not good. That's undefined. All right, so after that, as long as n is some non-negative number that's not 7, we can continue. Alright, so the numerator, I have the square root of 5, and I'll keep it factored for now, times that square root of n plus the square root of 7, divided by, then just a difference of squares. It'd be the square root of n squared, which would just be n, minus the square root of 7 squared, which would just be 7. So the denominator is just n minus 7. No more radical. So this is perfectly good. All right, this is perfectly good. Now note, I'm not seeing any common factors. There's no factor of n minus 7 in the numerator to cancel with the denominator. So now I'll actually distribute the square root of 5, right? And now I'll distribute. So we have the square root of 5 times the square root of n would be the square root of 5n. They're both square roots, so I can put them together like that with the product property. Plus, and then the square root of 5 times the square root of 7 would be the square root of 35. So there's the numerator. And the denominator is, n minus 7. And there you go. All right, no common factors in the numerator and denominator. All right. And then, if you wish to check it, test it out. Replace n with any non-negative number you want except 7. Plug it into the original expression, plug it into the final expression for n. Use a calculator if you want, and you'll see that the values should be the same, no matter what you plug in for n. Again, as long as it's non-negative and not 7. All right, question 4, very similar. Once again, there's a variable. This corresponds to exercise 278. Numerator is the square root of 7. The denominator is the square root of y plus the square root of 3. So y has to be non-negative in order for us to be dealing with real numbers here. And y can be 0, right? Because if y were 0, the denominator would just be the square root of 3. And that's it. All right, y can be any non-negative number. All right. So now, multiply by the conjugate. Right. I'm rationalizing the denominator. So I'm multiplying the numerator and denominator by the conjugate of the denominator, the square root of y minus the square root of 3. And do the same to the numerator, the square root of y minus the square root of 3. And I'll leave the numerator factored for right now. We have the square root of 7 times the square root of y minus the square root of 3 divided by, and then we multiply these two conjugates in the denominator, we'll end up with y minus 3. Right, the square root of y squared minus the square root of 3 squared. And I'm not seeing any factors of y minus 3 in the numerator, so this is as simple as it gets, and then I'll just distribute the square root of 7 here. So this is great here. There's nothing wrong with writing this, but you could also keep going, multiply. This would be the square root of 7y minus the square root of 21, all divided by y minus 3. Alright, now notice because I multiplied by this over this, y can't be 3 either. So because I multiplied by the square root of y minus 3 in the denominator, right, y can't be 3, because then because if y were 3, see in the end here even, if y were 3, the denominator would be 0, and you can never have a denominator of 0. So I'll add that further restriction to the value of y at the end. Alright, let me circle that. Alright, then once again, if you want to test it out, just replace y with any non-negative number except 3. Alright, and plug it in the original expression, plug it in the final expression, and you should get the same value. They should be the same value. I leave that to you to test. Alright, and then I have one more page here where it's pretty similar stuff. It's just now the numerators also have 2 terms. So number 5, number 2, which is number 280 in the text. We have the square root of s minus 6 in the numerator divided by the square root of s plus the square root of 6. So hopefully it's obvious that s has to be non-negative. And I'm going to be multiplying by the conjugate here, so s can't be 6 either. You'll see in a second. Alright, because if I multiply by the conjugate of the denominator, well, that would be the square root of s minus the square root of 6. Alright, so s definitely can't be 6, because then I'd be multiplying the denominator by 0, and that would be bad, right? You can't have denominators of 0. And the numerator has 2 terms, multiple terms, so I'm putting that in parentheses as well, and that's getting multiplied by, that same conjugate, the square root of s minus the square root of 6. Alright, so the numerator is actually the same thing twice, right? It's the square root of s minus the square root of 6 to the second power, right? It's the same factor twice. So it's that factor squared. Divided by, and then, s minus 6, right? The square root of s squared minus the square root of 6 squared. And, pardon me, I don't see a factor of s minus 6 in the numerator, so this is perfectly fine. This is perfectly fine. But you could also multiply these two by foiling. Distribute the square root of s. You'd get s, right? Then minus the square root of 6s, and then minus another square root, and then I'll distribute the negative square root of 6 and get another minus the square root of 6s, so minus 2 times the square root of 6s, and then plus 6. Right, negative root 6 times negative root 6. So there's the numerator if you multiply it out completely. And the denominator is just s minus 6. Right? And again, there are no common factors here. This is it. This is fine. Again, this is fine as well. All right, nothing wrong with this either. I just like multiplying things out. All right, and once again, if you want to test it out, go to the original expression, plug in any non-zero number for not non-zero, non-negative. Plug in a non-negative number for s that's not 6 in the original expression and the final one, and they should give you the same value. And finally, question 6 here, very similar. Hoping you can tell, these are all square roots again, so m has to be non-negative, but also m can't be 3. You'll see in a second, because I'm going to multiply by the conjugate of the denominator. And I don't want to multiply denominators by 0. So the numerator and denominator both have multiple terms. I'm going to put in parentheses around them. I'm going to multiply the denominator by the conjugate, right, the square root of m minus the square root of 3, and the same multiplied by the same expression in the numerator, the square root of m minus the square root of 3. Alright, so the numerator is just the same factor twice again, so a nice square is the square root of m minus the square root of 3, that quantity to the second power. Divided by, and then multiplying these two conjugates gives me a difference of squares. The square root of m squared, which would just be m, minus the square root of 3 squared, so minus 3. So this is perfectly well and good. There's nothing canceling here. You can circle this if you wish, or if you multiply the top out, distribute the square root of m, then distribute the negative square root of 3, do all the foiling, you'd have m minus 2 times the square root of 3m, and then plus 3 in the numerator, and then m minus 3 in the denominator. Right? Again, rationalized denominator, right? The denominator doesn't have a radical anymore. All right, and one more time, if you wish to check your results here, test it out, just replace m with any non-zero number that's not 3. Sorry, non-negative. I said non-zero again. Replace m with a non-negative number that's not 3. Put it in the original expression, put it in the final expression, you should see the same result no matter what you plug in for m, right? As long as it's non-negative and not 3. Great. All right. So that's it. I'm hoping that watching me go through these 6 questions here helps you in some way when you are asked to rationalize a 2-term denominator on your own. And thank you very much for watching.